Okay, Martin, do you want to talk about the embedded causal cluster feature we have?
Yes, absolutely. So Neo4j, as you might know, has started out as an embedded database, and then we moved over to being a primarily server product. There are a lot of customers using that together with HA historically, but of course we want everyone to move over to Causal cluster, and this has so far not been possible for those customers still stuck on HA using embedded. So now with 4.1, you'll be able to use new factory and builder pattern to create causal clusters. And there is really not much complication around that itself. But if you're moving from HA, you have to be aware that now you have to package all the work you want to do as Cypher, meaning either it's direct Cypher queries or you need to package the accesses you've been using when you've been using the Java API. You need to package that as procedures and invoke them remotely using Cypher. And also need to think about the routing. If you're routing from within the application that is like running the cluster node, or if you have an application on the outside of the entire embedded application, you can also use the driver to route the work and load balance the work using an embedded or an external Neo4j driver. So if it's embedded, of course, that would be Neo4j Java driver. But if you're on the outside of this application, which has the Neo4j database server embedded, then of course you can use any language. But with those two limitations in mind, it is now possible to use an embedded causal cluster. Some additional things to maybe keep in mind, of course, as usual, this doesn't change as such from HA, is that you're sharing a server, a JVM, with some other piece of code, and it's important to leave room for the server to function correctly, so that application doesn't, of course, eat up all the resources from the database. Yeah, that's probably it. So maybe Ragnar, you would like to talk about leadership transfer and control and balancing.
Yes, thank you. So in 4.1, we have improved the control of writability, where you want to write, which is basically where you put your leaders. And we've also introduced balancing of leaders so that we can distribute the write load more evenly within our cluster. So what we have done is that we have extended the RAF protocol with something called the leader transfer extension, which is a way for a server who is currently the leader of some database to ask another server to take over that leadership. And this allows us then to do a few things. So it allows us to control leadership in a safe way. If we, for example, want our writes to go to a specific place to a specific database, for example, over another database. And it also allows us to, in a multi-database scenario, balance the leadership, as I said, to have a more equal load on the system. We also can use it when we shut down. So for example, if you need to shut down a member and because of maintenance or something like that, before the member would just leave the graph group, which means that it would take time for the other members to understand that the leader is gone and they would have to elect a new leader. Now instead, it would actually try to pass all the leaderships over to other instances before it shuts down. So it should reduce the write unavailability that you would possibly get when shutting down instances. So the reason why you would want to control leadership is because you, for example, have some servers that are more suitable to become a leader than others. So it could be that you have a data center in different continents. You could have one data center in the US and one data center in in Europe, for example, and in that case you might want, it's more preferable for you to have the rights going to the center in the US. Before, the only option you've had is to refuse to be leader, which is an option that we don't recommend using. And so we wanted to provide something that is more safe and that we sort of approve of. And this is what I will talk about in the next slides. So I will move on. So firstly, the balancing. In 4.0, we introduced the possibility to have very many databases within the cluster. And we already have some customers working on scenarios where we have hundreds of databases. Of course, we want to be able to use all our members so that not one member is doing all the load. So what we've introduced in 4.1 is a very simple load balancing strategy where we basically just check the amount of leaderships on all members, and then we try to even that out. So it's if I am a member who have more than 2 leaders, more than anyone else, I will give a leadership up to someone with fewer leaderships. So within time, it will get the equilibrium where we should have an equal distribution of leaders. See if there's anything. Oh yeah, regarding the balancing, we do not balance any leaderships today that are having configured to be in a specific server group. So it's something we will do, but it's not in yet. It could be good to know. So currently, if you want good balancing, don't try to control it. The groups are not meant to control leader balancing. It's meant to control writability. So try to keep them a bit separated. The balancing strategy we've chosen is pretty simple, and we're very open for creating more intricate versions of it. So we're very happy to get feedback on how the balancing is working. A simple count that we have today doesn't necessarily need to mean that the load is evenly distributed. It only means that the leaderships are evenly distributed, but we could still see the case where maybe core 3 has the leaders that are doing the least work, and core 2 have the leaders who are doing the most work. So even if the count is the same, the load could be very different still. So there's definitely a lot of different kind of strategies that could be used. So we're definitely interested in getting feedback and so on this, and to understand how we can improve it and what kind of strategies that could be useful for different customers. I will move on to the preferred leaders. And the preferred leaders is our new way, as I said before, of being able to put leaderships or desire to put leaderships in specific servers. And it uses the same server group interface that we use in our load balancing already. So what you do is you configure your servers with the server group where you want the leaderships to go. In this slide specifically, we have group 1 and group 2. So we have 3 cores who have been configured to have group 1, and then we have 2 other cores who are in group 2. And then we have 3 different databases installed, the yellow and the green and the pink. And as you can see in the config, we've now set the leadership priority group for each database. And all of them have been told you should be in group 1. So that means that we want all of these databases to have their leaderships in group 1. And the way it works is that we will periodically completely check the state of our leaders. And if there is a member who has the leadership of a database, but it shouldn't be on that member, it will try to pass that on. Once all configured priorities have been, are in the correct place, so we will always put the highest priority on putting the configured prioritized groups in the correct place. Once that is done, then we will move on to the automatic load balancing to do so. We have designed this to be very not invasive because we do not want to create any unavailability. So we're very careful when passing on leadership, which means that it might not happen the first time, it might not happen the second time, but it will happen, and it should even out in within time it should even out. And so we ran some tests on this. We did with 100 databases. After just like messing about with the cluster and forcing all of them to rebalance, it would take about 2 minutes for them to find an equilibrium in that situation. I think that is all I have about the.
Okay, that's